All right, good morning, afternoon, or evening. How are you guys doing today? I hope you're doing well. Today we're going to start talking about mixture problems. Now, mixture problems have a lot of different types, involved in them. You can have mixture problems with money and the amount of tickets sold, for example. That's a popular one. You can have mixture problems where they tell you you have two different items for certain prices, and they want you to combine them together, and they want you to find how much of each item you made, you put in to make this combination. For example, like trail mix. You do know that there is a specific mixture for trail mix. They just don't take a handful of this and a handful of that and a handful of the other. They go by cost. Everything in that trail mix costs a different price. So there's a specific, precise system of equations that tells them how much of each substance or item to put into that mixture. And then the real problem here is the type of questions that ask you for percentage of a certain liquid or of a certain dry substance. For example, they'll say like a 20% solution of acid is mixed with a 38% solution of acid. How much of each type of acid was mixed together to create 40 liters of a 27% acid? That's the one that kills people. So what I'm going to do today is we're going to do this a little bit differently. I'm going to show you right from the beginning how to set this up like a direct translation. Okay, because these are the easy ones. But then from the direct translation, I'm going to show you how to set up these little beakers, is what I call them, so that when you get to the really crazy tough ones, you're used to the beakers, and you can go forward from there. Okay? So, first example. A one-day admission ticket to Cedar Point Amusement Park costs $42.95 for adults, $15.95 for children. Two families purchased 9 tickets and spent $332.55 for the tickets. How many adult tickets did the families purchase? First off, remember to label your variables. First and foremost, above anything, remember to label your variables. So for this particular example, I'm going to go ahead and say that X will be my adults and Y will be my children. Could you have used different letters to represent adults and children? Yes, absolutely. The answer is absolutely yes, 100%. However, you have to define or label your variables. If not, it's going to be very, very difficult. Okay, now, from direct translation, which we have already talked about, it's pretty easy to see here. Well, if I bought a total of 9 tickets, right? Hey, we have here, oh my God, why is this happening? I'm sorry, guys. This is, I don't know. Keep current color scheme. Leave me alone. Okay, 2 families purchased 9 tickets. So doesn't that mean that the number of adults plus the number of children had to be 9? That makes sense, right? It's a direct translation, correct? And then, don't we know that $42.95 for every adult plus $15.95 for every child has to equal $332.55? Does that make sense, guys? Okay. We can pretty much all figure that out. That's nice and easy. That's a direct translation. However, when we get into the more difficult types of problems, doing it like that is not going to give you a nice, easy way out. So what I'm going to teach you today is how to set up these little beakers. Don't stress out about the beakers, okay, guys? All I did was I drew a little box without a top. There's a certain amount on this side and a certain amount on this side. And when you combine those two together, you get one full beaker at a completely different size. That's all I drew there. Now, what is this made up of? Okay, well, here on the outsides, okay, I just covered what I wanted to show you. Here on the outsides, you have the individual percents or rates or costs. The individual percents, rates, or costs. Here, down here, are the individual amounts. You're going to have two different amounts that you're working with because we're working with systems of equations. When you set these up and you combine them, this inside of here is going to be the total of the mixture, percent, or rate, or the total cost. This down here is the sum of the individual amounts. Amounts of the individual amounts. And that's it. Now, how does this work with what we just were given? Check it out. We know that we have adults are X and children are Y, correct? So I have adults X and I have children Y. Why? Because these are the individual amounts. We don't know how many adult tickets we bought, and we don't know how many children's tickets we bought. Does that make sense so far? Promise? Okay. Now, how much was each adult ticket? $42.95. So adult, $42.95. How much was each children's ticket? You have it written down on your paper, guys. $15.95. Okay. What was the total amount of money they spent? $332.55. What was the total number of tickets they purchased? 9. Now look at what I have here, guys. Don't I have here 42.95 times x is 42.95x? Y times 15.95 is 15.95y. And we already have my total of 332. So don't I have 42.95x plus 15.595y equals 332.55? And my second equation, doesn't x plus y have to equal 9? Does that make sense? Now, a lot of people do not like working with decimals. So what can I do to this top equation here if I want to get rid of the decimals? Multiply by 100 to everything. So if I multiply by 100 to everything, I'm going to get 4,295x plus 1,595y equals 33,255. Does that make sense, guys, what I did? How I set that table up? Trust me, I know. There's something inside of you saying, no, I don't want to do this. It's easier the other way. I understand, and that's fine. You want to do it the other way, that's fine. But trust me, when we get to the percent problems, you're going to love this. So that's why I want you to practice this now. Okay, so let's solve it. Okay, which one do you guys want to solve, the decimal or the whole number one? Because I don't really care. It doesn't matter to me. Whole number one? Okay. So I want to eliminate. What do I want to eliminate, the x or the y? You want to eliminate the x or the y, I said. Okay, let's do the y. So I'm going to multiply 1595 to both sides. So what am I going to get? I'm going to get negative 1595x. The y's cancel, right? Well, minus, let's just do it the right way. 1595y equals 9 times 1595 is 14,355. Okay? Does that make sense? Okay. Yes. Yes. Hey, good catch. Yes. If you wanted to use substitution, that is perfectly fine. Okay? Because if substitution, what would you have done? Exactly. If you wanted to use substitution, all you would have had to do is say x equals 9 minus y. And we're having a little bit of a delay here today, but yes, x equals 9 minus y. If you so chose to do that, that's fine. Okay, but we're going to be going ahead and doing it by elimination. Okay? Yes, sir. Yes, sir. Something like this, not really, because you already got rid of the decimals. So you don't really need the calculator, right? You could, again, you can do that out. You don't need a calculator for that. No, you do not need it. Okay, guys, so now what happens here? Okay, we have 4,295 minus 1595x. And what is that going to give us? That is going to give us 2,700. And of course, it's not working today, so no big deal. So we've got 2,700x equals 33,255 minus 14,355 is going to give me 18,900. Divide by 2,700. Cancel the zeros. And x will equal 7. Of course, you plug it into the other one, absolutely. Now, it's not very pretty, guys, but in life, is everything going to be pretty? No. So we just got to work it out. Okay? Is everyone with me so far? Promise? Okay. So now, exactly like my boy said, we plug it in, right? If I know that x is 7, well, then I have 7 plus y equals 9. Y equals 2. Now, at the end, what's my final answer here? I've got 7 adults, because remember what I said from the beginning. You got a label, and 2 children. Does that make sense, guys? Promise? Sir? And the test, yes, I would always like you to put in the ordered pair, please. Always. Thank you, my man. I remember if you use something other than X and Y, it's ordered pair because it's what kind of an order? Alphabetical. Very good. May I continue, my brothers? Okay. Let's do this. Okay. A third grade class contributed $9.20 in dimes and quarters to the Red Cross. In all, there were 56 coins. Find the number of dimes and quarters that the children contributed to the Red Cross. Okay. I know the temptation. Oh my God, I want to solve this like a direct translation. I know, I promise you, you will be able to if that's how you feel comfortable. But today is to try to figure out how to use this little model that I created, okay? So, okay. What do we have here? Individual rates go on the sides. The individual amounts, some of the individual amounts. You guys with me so far? Okay. So, what do we always do before we start anything? Label. Very good. So what do you guys want to call X? You want to do, okay, I had done it differently, but okay. All right. Let's go ahead. No. Let's go ahead and do X is quarters. And Y is dimes. Okay? Does that make sense? So if that's the case, that's my, okay, that's my X. And X is quarters. How much is the value of every quarter? What? That's exactly right. 25 cents, right? And then what's my other variable? Dimes, which we call Y, correct? And what's the value of dimes? That's exactly right. 0.1, 10 cents, correct? Okay. What was the total amount of dimes and quarters they collected, boys? No, I'm sorry. I messed you up there. That is correct for these 6. And what is the total value of all the quarters and dimes? Perfect. Guys, do you see how I filled that table in? No, but don't just say yes. For real, do you understand that? Did you see how it just kind of like flowed into place? Promise? Yes, sir. Okay, 56 down here, right? Why? Good question. Aren't these the individual amounts? Don't these individual amounts come out to be 56? Bam. Hence the individual amounts and the sum of total. Does that make sense? Thank you, guys. Now, to get our values, to get that 920, if it's 25 cents for every adult, then they paid 25.25x, correct? Depending on the number of, and not adults, depending on the number of quarters, right? And For the dimes, it's 0.1 or 10 cents for every dime they collect. And that should be a Y, guys. Sorry, little typo there. That should be a Y. You guys with me? Okay, so what do you think the system is going to look like before I just show you? Talk to me. Hold on. Go for it, my man. I don't think I could have done it better myself. Awesome. I don't like working with decimals, though. I don't like it. What do I do? Multiply by 100, absolutely. So what am I going to get? Perfect. Does that make sense, boys? Okay, so now, how do I solve it? What do you guys want to do? Substitution, elimination? Elimination, yeah, I would definitely use elimination here, right? Who do you want to get rid of, obviously? Exactly. So let's go ahead and actually, wait, nope, that should be a 10 there, right? Yep, that should be a 10. Because I multiplied by 100, So yeah, negative 10. So I got negative 10x minus 10y equals negative 560, right? So I got 15x, y's cancel, and 920 minus 560, 360. Okay, good job, guys. Come on, man. Get on that. You guys with me? Yeah. Okay, how do we solve for x? Divide by 15. That is absolutely correct. And that is going to equal 24. Does that make sense? What do we do now when we have that 24? You plug it into the other equation. Absolutely. So 24 plus y equals 56. Subtract 24 to both sides. Y will equal positive 32. So am I done there, or do I need to define what I just solved for? That's absolutely right, gentlemen. So I've got 24 quarters. Why? Because we labeled them from the beginning. Comma 32 dimes. Why? Because we labeled them from the beginning. Does that make sense? Okay, prove it to me. Set this one up on your own, boys. I'll give you a minute, okay? I'm going to pause the video. I'm going to give you a minute. Check it out. See if you can do it, okay? All right. First off, always remember on that, I'm sorry, that should have been, that should be blocked off. Sorry, guys. Well, pretend that's not there. Your boxes, I saw that some of you guys are drawing them a little bit weird. Remember, your first beaker, it's actually two different beakers of two different amounts. And they are creating one huge beaker of one amount that they tell you. You with me? Okay. So, I have $12,000 to invest in a money market account that paid 6% annual interest and a stock fund that paid 8.5% annual interest. Suppose that you earn $807.50 in interest at the end of 1 year. How much was invested in each account? Okay, guys, what's the first thing we got to do? Label. Very good. So I'm going to go ahead and say that X is the amount of money that I placed into the 6% account. And I'm going to say that Y is the amount of money that I placed into my 8.5% account. Does that make sense? That's my X and my Y. So I have my X and I have my Y. Does everyone see that? You promise? Hey, it's not in the box, is it? It's on the bottom, right? Okay, what is the percentage paid for the X account? 6%. Very good. What is the percentage paid for the Y account? 8.5, which we already have. Now, what is the total amount of money that you could have put into both X and Y? 12,000. That's my total right here. Do you see that? Yes. Sir? We don't convert into a decimal yet, please. Okay, is everyone with me so far? Yes. Okay, what's 6% times X? Okay, it's not 6X. 0.06x. Very good. And 8.5% times y? 0.085. Oh my God, I did it again. That should be a y. Okay? And what is the total amount that they earned? So that's where the total goes. Now, for those of you that are having trouble building this, where can I help you? Does that make sense?
Yeah, I was just confused what the x and the y equal.
Well, what the x and the y equal, you're going to be confused forever if you guys don't label. Remember how important I said that was from the beginning? Yes, sir. Okay, thank you for asking. Don't you have an account X plus you put some money in account Y, correct? Didn't I have 12,000 to put into that? X plus Y equals 12,000, right? Does that make sense? So now, what would the systems look like? Go ahead.
0.06x plus 0.085y equals 807.5.
Perfect. Kind of like that?
Yes.
Perfect. What if I don't want to work with decimals? Multiply the top by 100, which should give me that. Correct? Does that make sense? You guys with me?
Yes.
Okay. How do I solve now? How do I solve? I'm going to go with the non-decimal one, right? Okay. What do you want to do? You want to get rid of the x or the y? I will get rid of the x as well. Okay, so I'm going to multiply what to both sides? That's exactly right. So that gives me negative 6x minus 6y equals negative 7,200. My x's cancel. My y is 2.5y. And that is going to equal 8,750. Divide by 2.5. And y will equal... I cheated. I already did the calculations. Go ahead. Yes, sir. You could have multiplied everything by 1,000. You're right, son. I just didn't want to go so large, me personally. But yes, if you wanted to get rid of every decimal, for sure you could have multiplied by 1,000. Excellent, excellent, excellent. Does that make sense, guys? Okay, so when I have that, I'm going to have that my y is $3,500. Does that make sense? Okay, plug it in. What do I get as x? Plug it in. Do it. Come again? That's exactly right. Good job, guys. 8,500. Does that make sense? Okay, now, are you ready for the real magic? Because this was just a teaser. You ready for the good stuff? All right, let's do it. Okay, before we start, guys, whenever they talk about a pure substance, please realize that that means that it is 100% of that particular substance. Exception, water. H2O is neither an acid nor a base. Okay? So what happens is when they say pure H2O, it's as if you're adding nothing. It's 0% because it's neutral. It's not an acid nor a base. So that's good to know because it's going to come down later in the pike. Okay. You're an ice cream maker and decide that ice cream with 9% butterfat is the best to sell. How many gallons of ice cream with 5% butterfat should be mixed with ice cream that is 15% butterfat to make 200 gallons of the desired blend? Okay, guys. Would this be easy for you to set up in a direct translation? Be honest. Not really, right? You got a lot of percentages there, don't you? And you only got one total there, don't you? That makes it a little bit more difficult, doesn't it? Okay, that's why we created this graph. Okay? Yes, sir. It shouldn't be. No, I told you to download the correct one. Okay, so what do we got here, guys? What do we got to do first? Label. What do you want X to be? The 5%, the amount of 5%. What do you want Y to be? The amount of 15%. Right? You guys with me? So I have an X and I have a Y. You with me? Okay, what's the percentage of the X? Guys, read. What is the percentage of the X? 5%. What's the percentage of the Y? 15%. Okay. How many total gallons am I creating? So X plus Y has got to be 200. Okay. What is 5% times X? 0.05X. What's 15% times Y? And that should be a Y as well. Jesus. 0.15 Y. And what is the percentage of the final mixture going to be? 9%. So what is the total amount of that? What's 9% times 200? What's 9% times 200, guys? 18. Fill it in, guys. If you don't fill it in, you're not going to get the rhythm of this. You don't get the rhythm of this, it's going to be extremely difficult at home. Does this make sense to you? Yes, sir. This is area, guys. I'm basically finding little areas. What's the area of a rectangle? Base times height. What's the area of this rectangle? Base times height. What's the area of this rectangle? Base times height. Does that make sense? Okay. So now, what are my equations here? Uh-huh. Equals 18, yes. I don't want to work with fractions, so multiply everything by 100. Bam. 5x plus 15y equals 1800. Yes, sir, my brother.
With the second equation at the bottom.
Yes. Absolutely. Yes. This is wrong. This is wrong. Sorry about that. That is 200. Good catch, kid. Thank you. Thank you, thank you, thank you. Good catch. Thank you very much. Awesome. Okay. Does that make sense, guys? Now let's go ahead and solve it. I'm going to get rid of the x. So it's negative 5x minus 5y equals negative 1,000. Cancel, cancel. 10y equals 800 divided by 10. Y equals 80. Plug it in. X will equal 120. Okay, so I have 120, which was this, liters or millimeters? This was gallons. So 100 gallons, okay, 120 gallons of the, this was of the 0.5%, or the 5% mixture, comma, 80 gallons of the 15% mixture. And that is exactly what I have to do, combine, to make a 9% mixture. Yes, sir?
Last year, I did the chart. I wanted to show you, like, to see if it was right. I did this last year.
Okay, if you do this a different way, with a chart that you like, and you understand it, and that works for you, am I going to allow you to do that? Of course. I'm not here to tell you that my way is the best way. I am here to teach you the way that I always found it best for me. So if you have a better way for you, God bless you. Awesome. Thank you, my man. May I continue, boys?
Yes.
Okay. Next. You have $20,000 to invest. You invest a portion of your money into one account paying 12% interest and into another account paying 8% interest. After 1 year, you earned $1,800 in interest. How much did you invest in each account? Okay, let's draw my beakers. Let's label. I'm going to call X the amount in the 12% account. And I'm going to call Y the amount in the 8% account. How much money did I have to spend? $20,000. So doesn't the amount I put into the 12% account, X, plus the amount I put into the 8% account, Y, doesn't that equal $20,000? What is the percent that the X account pays? 12%. What is the amount that the Y account pays? 8%. 12% times X is 0.12X. 8% times Y is 0.0X. Oh my God, 0.08Y. My God, I made a mistake on every one of those. Sorry. Okay? And what is the total amount of interest that I have? 1,800. So, my equation is easy. I got 0.12X plus 0.08Y equals 1,800. That's the interest. And X plus Y equals 20,000. Or, if I want to work with non-decimals, multiply everything by 100. Yes, sir. Why didn't I multiply what this time, my man? I have nothing to multiply. This is an area. 20 times what? I don't have anything here to put. I can figure it out. That's going to be 9%. But I'm not looking for that. All I was given, my man, was the fact that I have a total of 1,800 earned. And this is the total of the mixture percentage or the rate or the total in money. You with me? Thank you, my friends. All right. So now let's solve it again. I'm going to this time solve for Y. For X. I'm going to get rid of Y. So that's negative 8X minus 8Y equals 160,000. That's 4X equals 20,000. Right? My numbers are right. And divide by 4. So X equals $5,000. So when I plug it in, Y is going to be $14,000. So I have $5,000 of the 12% account, and I put in, huh? Well, first I put 5,000 to the 12% account, which was X, and then I put 1,000 into my 8% account. Talk to me, guys. Does that make sense? Promise? Okay, let's do another one. Okay. A store manager mixed together nuts and M&Ms to make a trail mix. The manager created 10 pounds of the mix and sold it for $5.10 per pound. If the price of the nuts was $3 per pound and the price of the M&Ms was $6 per pound, how many pounds of each type did he use so that the value of the mix was the same as the value of the individual items? Okay. Let's see what we got here. First things first, I'm going to call X the nuts, the amount of nuts actually. The amount of nuts that you used. And my Y is going to be the amount of M&Ms you used. Does that make sense? I'm going to make my beakers. I know that I have an X, which is my nuts, Y, which is my M&Ms. How much is the cost of the nuts? $3. How much is the cost of the M&Ms? $6. Okay. How many total pounds did I create of the individual nuts and M&Ms? 10 pounds. 3x plus 6y has to equal what is the total amount that they're going to charge for this mixture? 510. I'm sorry, 510, which is 51. Sorry. Does that make sense, guys? Are you sure? We're talking about areas again, okay? Remember, areas. This rectangle, base times height. This rectangle, base times height. This rectangle, base times height. Yes, sir, I saw a hand here. Yes? No, I've done this all the same. Every single one. Okay, was I always given this amount? No. In this case, I was given this amount. Sometimes I'm given this outside amount, and then I calculate my total. Because they'll tell you. Okay, did they tell you how much the whole entire 10-pound package was going to be? No, they told you what the individual would be. Thank you, Pablo. Great question. Thank you. So now my system's really easy in this one. No decimals. 3x plus 6y equals 51. Go ahead and multiply negative 3 to both sides. So I got negative 3x minus 3y equals negative 30. X's cancel. 3y equals 21 divided by 3. Y equals 7. So that means that when I plug it in, x equals 10. So I have 10 pounds of nuts, comma, and 7 pounds of M&Ms. X equals 3. Maybe I should learn how to add. Yes. Thank you. Does that make sense, guys? I hear a lot of heavy breathing. Are we okay? Okay. Let's see if you can set up this last one. Last one of the day. I'm going to hit pause. See if you can do it. Okay, guys. As I walked around, a couple things that I noticed. People are not labeling. If you don't label, you won't know what to do. Period. So I'm going to call X the amount of 12% solution. And then I'm going to call Y the amount of 20% solution. Now I'm going to draw my beakers. Okay, because they tell you, they want you, they has asked you to prepare a 4 liters of 15%. Looking into the supply room, there is a bottle of 12% HCl, which is my X, and another of 20% HCl, which is my Y. A lot of people do mess up like that because they don't read. Be careful. Thank you, sir. So now, I have my individual amounts. The amount of the 12% is 12%. The amount of the 20%. The total. What is the total size, volume of the mixture they want you to do? 4. And what is the percentage of the new mixture they want you to have? 15%. So I got 0.12x plus 0.2y equals 0.6. And I got x plus y equals 4. Talk to me, guys. Where are we not making that connection so I can help you? Sir. On the other side, okay. On the right side. This here. Yes. Okay, look. They told you that they prepared 4 liters, correct? Isn't that the total of the individual x plus y total amount? Right? Of that total amount, aren't the sides, according to what I said, aren't the sides the individual rates, percents, or costs? They said that the individual percent of the x was 12%. The individual percent of the y was 20%. Did they not say that it's 15% of the combined new beaker? You see what I'm saying, my man? Thank you. Great question. So now it's area again. X times 12%, 0.12x. Y times 20%, 0.2y. 4 times 15%, 0.6. Does that make sense, guys? So my equations, either decimal form or non-decimal form. And now, you multiply by, let's say, negative 12. So I'm going to get negative 12x minus 12y equals negative 48. Cancels. I got 8y equals, what is that, 12, right? Yeah. So divide by 8. So y is going to be 1.5, and we're talking about liters. And when I plug it back in, x would be 2.5 liters. So my solution, 2.5 liters of the, look at my label, of the 12%, and 1.5 liters of the 20%. Does that make sense? Yes, sir.
I can put it in fraction.
No, you can put it in fraction or decimal, but in this case, it's an easy decimal. Thank you very much, guys. I hope you learned a lot.